So we've put up a couple of examples of this. This works very much like the workshop problems that we did with the comparison test, just we're doing it with the general term of a series. So I want to ask, does the series sum from n equals 2 to infinity of n squared over n cubed minus n converge or diverge? So in order to answer that, what we're going to do is we're simply going to observe. First of all, we're going to say that we're going to answer this by the DCT. You always want to state the name of the theorem you're using. So let's observe that n cubed minus n is going to be less than or equal to n cubed, and therefore 1 over n cubed minus n is greater than or equal to 1 over n cubed. And therefore, if I multiply all sides of this inequality by n squared, I get n squared over n cubed minus n is greater than or equal to n squared over n cubed, which is equal to 1 over n. So finally, I have this inequality. I have n squared over n cubed minus n is greater than or equal to 1 over n, and for all n greater than 2, this is still going to be greater than or equal to 0. So I do in fact have an an and a bn. So this is going to be our an, this is going to be our bn, and what we can see is that bn is greater than an, and we can also conclude here that the sum of an, which equals the sum from 1 over n, sum of 1 over n, I'll put in the indices, but normally it's enough just to put a sigma just to be clear that you're talking about the series instead of the sequence. Since the sum of an, which is equal to the sum of 1 over n, diverges, and I want to state the reason that I know it diverges. Diverges because it's a p-series with p equals 1, which is less than or equal to 1. Therefore, the sum of bn, in other words, the sum from n equals 2 to infinity of n squared over n cubed minus n, also diverges. And that's the end of the proof.